I'll do that. Oh, background can. He says that initiate that. এই লাস্ট অ্যানাউন্সমেন্টটা কবে করেছিলেন? জুলাই না ওই মিডিয়াতে গেল যেটা আগেবার
वो जो मिनिस्ट्री एमएचआरडी का जो ये है ना पोर्टल है उसमें हम वो अप्रैल का दिया था लेकिन मीडिया को पता चला पहले जुलाई में उसके पहले उसको पता नहीं
जुलाई
वो अपना ये था चेयरमैन से भी मीटिंग हुआ था क्या नाम दे दिया इसका कविराज ये लगा फिर जो कर दिए तो कविराज ठीक
सर एक्चुअली क्या है
कविराज है तो आप कविराज जो जड़ी बूटी दिया
तो
करते थे
कंपटीशन में भी दे दिया जिसमें हम सेमीफाइनल में आ गए वो ग्लोबल कंपटीशन जो प्राइस उसमें भी उसका नाम है कविराज IIT खड़गपुर यही उनका नाम है मतलब हमारा टीम का
कविराज जो है ना वो भी एंशिएंट नाम है
राज से रैप हो गया तो थोड़ा मॉडर्न हो गया ना रैप डांस होता है ना उससे उसकी
रैप में
थोड़ा मॉडर्न
रैपिड सर हाँ समझ गया
তাহলে কি করব ওখান থেকে আমি না আমি করে দিয়েছি
ঘরে থাকলে আরো সুবিধা ভালো করে করতে রাজবাবু শুধু দেখে নেবেন লাইভ স্ট্রিমিং এ কোনো মানে বাজে নয়েজ যেন না আসে এটা যে ভার্সনটা নয়েজ ফ্রি আসে ইউটিউবে আর এতে ফেসবুকে সেই ভার্সনটাই আপনি স্ট্রিম করুন
আচ্ছা এখানে কি প্রেজেন্ট করতে শুরু না না সব করিয়ে দিয়েছি ग्रीन सिग्नल दिले আমরা
प्रोसीजर क्या है प्रोसीजर क्या है इसमें प्रोसीजर क्या है
शेवशी बोललो शेवशी बोलबे ना सर बोधहय शुरू
So I will
করবেন
start.
তারপরে
sir
प्रोसीजर क्या है
sir will start then our video which has been prepared will run then you will give the speech that what she may have told you whatever
what is that speech
no there's no speech
I will tell them
whatever then I will give a brief 2 minutes
details of the
not details I mean whatever because some most details are there in the video itself so I will tell only 2 minutes or so then it will be open to question no then ICMR director will give a she has already given 2-minute bite so that will be telecast one ICMR scientist is online she will also give who has actually tested our thing so she is there online that lady who is sitting one top virologist in India so she will give her observations on our machine method etc and then it will be open to discussion that is the thing so roughly 30 minutes of this structured thing and 30 minutes of interaction
okay
so who are physically here we are here that lady is there from ICMR who else is there
ICMR NICET director has given a recorded speech
right now who is
and others are all general journalists scientists like
speech मतलब उसको भी हम करना पड़ेगा
उसको that is ready Rajbabu knows he will do that
पहले ना आप कोई बोले उसके बाद में उनका बाहर वालों का सुनना चाहिए देन ही देन मी क्योंकि पहले उनका उसका हम लोग
नहीं सर, क्या है कि first we have to explain what it is. See, to the outside people, many do not have idea what it is. So we will explain this.
No. To those ladies and those people who will say about it.
Yes, but they
लेकिन
will
पहले
say
क्या है हमारा
क्या है हमारा, उसके हिसाब से ही वो बोलेगा ना कि क्या इसका परफॉर्मेंस क्या है, ये क्या है.
उसका ओपनिंग फिर आपको करना चाहिए हमारे ख्याल से.
नहीं
That's what I was thinking कि
हाँ.
हम initial
हाँ ऐसे कर लिए फिर he from the institute side he will tell, then I will say few things and then.
Sir, actually the best is the first movie should run, because then 80% of the thing they will understand.
नहीं ठीक है, बट उसमें थोड़ा सा आप 2-1 मिनट बोल के और तब मूवी के बाद करिए. और मूवी के बाद में फिर हमको उनसे बोलना चाहिए, देन ये बोलेंगे फिर हम बोलेंगे, उसके बाद क्वेश्चन. क्योंकि हम लोग ही पहले बोल रहे हैं तो उनका थोड़ा वैल्यू कम हो जाएगा. ये जो है ना
नहीं तो what he is saying is
लॉजिकल सीक्वेंस जो है
इसके बारे में तो हम कुछ नहीं बता रहे हैं. I'm just telling the backdrop and then
सर
he
आप
wants to
दोनों
run
का
the
क्या
bit.
है कि you are coming from the institutional point of view, hospital, affordable healthcare, these things. So it comes under this activity. So that broader thing, that is like where the institutional role is important. Otherwise, it will be like an individual research that we have done. It is not like that. It is a part of the institutional initiative. So that we want to highlight. That is why if two of you.
Yeah.
स्टार्ट with दीदी और कोई अभिषेक आप रेडी हैं.
Very good morning. I extend a very hearty welcome to you all who are present on this special occasion that we are going to have today. As you may be aware that IIT Kharagpur, which has celebrated its 70th Foundation Day this year and is heading towards the celebration of Platinum Jubilee, is imparting education in different areas, not only restricted to the aspects on the technology, but imparting technology in the area, education in the areas of management, law, and several other things. One of the unique schools that has been added to the fold of the institute is known as School of Medical Science and Technology. And this school is imparting again education in the area of technology to the graduates of medicine. IIT Kharagpur, in fact, is focusing its activities on different areas, different aspects like advanced transportation systems, advanced manufacturing, and several other aspects, including the most important things which we are calling as affordable healthcare. Today, it's very important that the country needs the attention on the healthcare. The School of Medical Science and Technology, along with the other associated departments and schools and centers of this institute, are focusing their attention to develop different kinds of devices, different kinds of methodologies, so that the healthcare aspects can be improved to a large extent. The COVID-19 pandemic, which is happening now throughout the world, though the whole world is suffering because of this pandemic, but this has given us an opportunity also to explore for various things. A group of scientists, our educationists from the School of Medical Science and Technology and the associated departments have come up to accept the challenge to develop certain devices which can help this pandemic situation. So today, in fact, we are here to tell you that this group of scientists, our educationists, who have developed a device which is named as COVID-App to carry out the test on the COVID-19 positiveness, and it can give instant result. And this is what is going to be talked about in details today. I would first like to show you a brief video on that, and then possibly we can move forward to have further discussion on this aspect.
IIT Kharagpur has come up with a magic box that can be a game changer in bringing high-end molecular diagnostic tests from the lab to the field and cater the needs of the underserved. This ultra low cost, portable, extremely user friendly machine can be handled by unskilled operators outside the laboratory environment and is all set up to act as an alternative to high-end Rtpcr machines. Premised on the functionalities of this machine, our team of researchers from IIT Kharagpur has developed a new testing method known as COVI-RAP for rapid diagnostics of COVID-19 infection. All what you need for doing the test is a small table which may be housed anywhere. You do not require an air conditioned lab and it can be put up even in a green field. Each test requires a kit which includes 3 master mixes which are made by our research team, and these are essentially markers of different genes to confirm the presence of the virus. The RNA sample extracted from the swab of the patient is first mixed with the master mixes kept in the small tubes. After the mixing is done, these tubes are put up inside the slots of this machine. This machine is pre-programmed for preset temperatures over which it will run for a period of time. Once this brief initial heating period is over, the reaction mixes are further mixed with a special solution and reloaded in the machine for another small heating step. This is an exclusive step which is patented by our research team to ensure the accuracy of the results and obvious simplicity in the testing procedure. After this step is over, simple dipstick like paper strips, very much similar to the pregnancy test strips, are then dipped into these reaction products and colored lines are gradually being developed within these strips. These colored lines are very critical because their existence confirms the presence and non-existence may confirm the absence of the virus. To do it very precisely, we have developed a customized mobile app that now takes over by grabbing the images of the test strips, where you can see that the test strips are inserted by a cartridge in the machine just in the same way as a credit card is inserted in a credit card reader. After the smartphone app grabs the image is analyzed within the smartphone and there is an inbuilt decision making system with the app that gives the final result of the test, COVID positive or COVID negative, in just a click. all these procedures starting from loading the sample to getting the result in the smartphone takes place within 1 hour. Tests on several patient samples can be done in parallel in one machine, and this makes this method quite scalable and versatile. After we developed this machine and the method, these were rigorously validated by the Indian Council for Medical Research or ICMR at the ICMR NICET using patient samples, a large number of patient samples as per their strict guidelines. Their test results have confirmed that the outcome from this machine and the method developed by our team is of supreme standards and comparable to the quality of the high-end Rtpcr tests to a large extent. Yesterday it was tuberculosis, today it is COVID-19, and tomorrow it will be something else. However, this generic machine unit is capable of performing molecular diagnostics for many tests of these kinds, which can be classified under the ambit of isothermal nucleic acid test or INAT. The diseases which could be detected are large in number, including influenza, malaria, dengue, tuberculosis and many others. By developing this machine, it is possible to empower common people to safeguard themselves from any unknown pandemic that may affect the human civilization over and again and potentially endanger our lives. IIT Kharagpur has come up with a magic box that can be a game changer in bringing high-end molecular diagnostic tests from the lab to the field and cater the needs of the underserved.
I am happy to announce that two of the innovators, Professor Suman Chakraborty and Professor Arindam Mondal, they are here with us. Also, we have with us our director, Professor V.K. Tiwari, and I would request Professor Tiwari to say a few words on this occasion.
Namaskar to all of you, and great congratulations to our friends here. In fact, we are proud of the whole team, Professor Suman Chakraborty, Professor Arindam Mondal, and other scientists who are there with them. We are in fact, COVID-19, when it struck all of us, the IIT scientists never sit idle. And in fact, in the month of March, April, late March and April, early April, we wanted to do something to take care of the pandemic as per the direction of the Government of India. And we wanted to have several aspects of precautions, including the equipment for helping our COVID-19 patients. And in this respect, this particular item offered creating one test by which we should be in a position to find out quickly because as we know that in Kharagpur we do not have a very good hospital, and anything happens we have to simply run to Calcutta. And in view of this, in fact, our situation was very precarious. And somehow or the other, our young scientists and students came up and they took up this challenge. As it is said that when going is tough, tough gets going. So our friends are tough, and they took up this challenge, and they came up. And in month of July, we had developed on the basis of the synthetic RNA the first level of the machine. But there was a need to know as to whether this machine is really giving accurate result of the similar quality as we get for Rtpcr. We had to do some confidential test with the help of ICMR, and we are grateful to ICMR that they maintained the confidentiality of the whole thing, and this has been tested over last 2.5 months, and now they have given a certificate to us. I think this is a great news. The whole ministry is thrilled about it. The minister would have come here to on this press conference, but suddenly there was a cabinet meeting today, and he's attending the meeting from 10:30, and that's why we could not. But I am sure that he's going to give his bite, and which will be also there in the media and press. With this, I again congratulate my friends, and I also welcome our the people from ICMR to say something on this, as they have been part with us, and we are grateful to them to have helped us in this journey. Thank you very much.
So good morning to all of you. We also have with us the representatives from ICMR NICET, who actually conducted very rigorously the testing procedure to test the efficacy of our method and machine. So we will be going forward by sharing the views of the director ICMR NICET, Dr. Shanta Dotto, followed by the views of Dr. Mamta Chawla Sarkar, who is a leading virologist from ICMR NICET and actually supervised the testing procedure. So I would request first to screen the views of the director ICMR NICET.
Land-based assay kit developed by IIT Kharagpur for detection of SARS-CoV-2 virus, which is the positive agent of current pandemic, has performed satisfactorily when the validation of the assay was carried out by ICMR NICET. On testing, it was found 93% sensitive and 98.6% specific at CT value 35-36 or below, and considering NIV third generation kit as gold standard. The kit performed better when CT value was considered 30 or below with 98% sensitivity and specificity. This kit is user-friendly, does not need any sophisticated equipment or skilled personnel. The assay was accompanied by a machine to capture the test results and to show the analyzed data in the form of positive or negative. This machine can be used at the peripheral lab. This testing assay may be recommended for scaling up for commercialization. There is scope for further improvisation of the kit for better performance. I wish the kit to be used at every lab at the national level. Thank you.
Dr. Chawla, sir. I would thank the director NICET for her comments, and then I would request Dr. Mamta Chawla Sarkar, the leading virologist from ICMR, who actually supervised the testing procedure, to give her comments. She is live online and she will now give her comments.
Good morning, everyone. And I would like to congratulate Dr. Suman Chakraborty and his team for the development of successfully development of assay. At ICMR, NICET Virology Lab is a validation lab recognized by ICMR. And using the SOP as given by ICMR, we actually tested 200 clinical samples, both positive and negative, in parallel. We tested with real-time PCR, and then also they were like labeled. There was a blind labeling, and then these were tested by the CoviRep assay version 1 by both the technical staff at ICMR NICET as well as the scholars from IIT Kharagpur who had come for training us for the assay. And the assays were comparable. Initially we were skeptical, but like we were quite delighted when we actually matched the results after the assay was over. The box which is developed by the IIT team works as good as a PCR machine. So it is very easy to use, and any technician who can do basic microbiology techniques can actually handle the machine. And the app which is developed also reduces the human error. So if a person does not have to declare the result, looking at the result, but a machine does it automatically, the error rate goes down because there's a person-to-person difference in opinion for all the tests. The test took less than an hour to do. So the advantage of LAMP assay over real-time assay is that it can be set up in the rural areas where there is a basic microbiology lab like TB testing lab. It does not require any expensive equipment and does not require a trained molecular biologist. So I would wish the team success, and we hope that we will actually improve this assay in collaboration in future. So we want to develop it and make it much better. Thank you.
Thank you.
So I would personally like to thank the director of ICMR NICET and also Dr. Mamta Chawla Sarkar, not just acting as testing labs for our machine and method, but giving us continuous scientific feedback and improvement towards developing this. And I believe that this collaboration with ICMR will continue with the kind help of these outstanding scientists over the next few months or years, when we will be developing further versions of this method and machine. I would like to summarize the discussion from our end before we take it forward for question answers. So the method and machine has been summarized in the video presentation to a level which is addressable and understandable by common people. Of course, there are several more details, but I would like to address one or two questions which are commonly, the questions asked by several others to our team members. And a priori, because I am aware of those questions, I would like to address one or two of those. So first of all, how do we put our method and machine in perspective of the other tests which are available not only in India but all around the world? So there are two distinct types of tests which are commonly being done. One is the RTPCR gold standard test. All of us are aware of the quality of results, but at the same time, the kinds of infrastructure and resources what is needed. The alternative tests which are being extensively used now for mass scale screening, the rapid tests, the elegance, cost, everything is very favorable, but the challenge is the quality of the results. And it is told that the rapid tests, even if they are inaccurate, if the rapid tests are done on a regular basis, maybe they can give some indicators of the progress of the disease, but the basic foundation of the relative inaccuracy of the rapid test remains to be a question. So we wanted to develop something which is a kind of hybrid between the basic scientific principles of the RT-PCR test and at the same time carrying some of the elegant steps that the rapid tests include. There are large number of new tests and kits introduced by various academic institutions and researchers, and we wanted to be different from that. As a scientific researcher, my aim is not just to copy, or my team's aim is not just to copy the RT-PCR method and bringing up a kit and claiming that we have done something, or some variant or simple variant of the RT-LAMP test which has been introduced like CRISPR and all those things published by other researchers and just copying it and claiming that we have developed a kit. As a scientist, our vision is to develop a method which is unique and exclusive in its own in terms of scientific merit. In the process, it gets generalized, it gets strongly validated so that in future this method can in generality be applied in many other contexts and not just COVID-19. This is true for the test method, this is true for the machine in all respects. The video that we have demonstrated is a simplified version of the entire thing just to demonstrate that this test can be conducted outside the lab by people who are not highly trained to do the test. So I must mention here that several steps of this test can be further professionalized and strongly bounded. In fact, in our lab we have made different versions of that, so that depending on the level of cost, depending on the needs of the lab, depending on the customization, all sorts of improvisations can be done. Like instead of using different strips, paper strips, we can reduce the number of paper strips, we can reduce the number of manual intervention steps, we can integrate the entire procedure starting from the swab collection to the test result taken in an integrated unit. So all these things can be done, and these of course are technologically important, and because many of you are interested about that means that everything is flexible. The test procedure can be simplified to an extent where minimally trained rural youth can perform the test, and even it can be put up in a lab where trained technicians can do the test. So this includes the generality and the uniqueness in terms of scientific perspective, where we believe that this particular test stands different from all the methods and kits which have been introduced by other academic institutions. So with this, I would like to thank all the participants, the dignitaries, especially our highest authorities of the institute, the Ministry of Education, the DSIR, Department of Scientific and Industrial Research, through their support by the CRTDH project, the IIT Foundation USA for their continuous support, ICMR NICET for not just acting as a testing unit but also giving us continuous scientific insights, and every well-wisher of IIT community, IIT Kharagpur community and the entire IIT community for standing behind us in these difficult times. Thank you all very much, and we can now open this session to interactive questions and answers.
We have already received a few questions. Anuradha from Indian Express would like to know what is the success rate, how many false negatives or positives are we getting in this, how safe it is for the health workers to use this machine.
So thank you very much for this question. So regarding the accuracy of the test, Dr. Mamta Chawla Sarkar just mentioned that after these tests were validated in different levels within our laboratory, these tests were validated with 200 patient samples, which included a balance of positive and negative samples with different viral loads, and in fact very low viral loads were also included. Within that set of samples, out of 200, so far as I remember, about 8 samples were detected to be not matching with the Rtpcr test results, and all of them or most of them were extremely low viral load cases. And if you consider the kinds of viral load cases which are normally accepted by the RT-LAMP based test kits, within that is in terms of the CT value, well, for our device there is no CT value because there is no thermal cycling, so there is no question of the cyclic threshold. But because it was compared with the Rtpcr test, we also have the CT values of the samples. And as the director ICMR NICET mentioned that the sensitivity is considering all CT values, that is extremely low viral loads is around 94% and specificity is around 98%. But if we take the CT value within 30 as a limit, the sensitivity, specificity both are very close to 99%, 98 point something. These are all data using patient samples and no in vitro samples. So that summarizes the performance of this particular method when it was tested by the ICMR NICET. So I think that
I would like to add here the particular numbers. So we have tested 200 patient samples, out of which we have given 115 positive samples, and our tests have fruitfully detected 108 out of 115 positive samples, and we have given 85 negative samples, out of which we have confirmed the negative test with 83 samples. For 2 of the samples we have failed. So so in total we have got 93.9% sensitivity and 97.6% specificity for samples having CT values from 25 to 35. That means from a very high to very low viral loads.
We have the next question from Priscilla Jebrad. She asks about the roadmap of commercial production. Has any deal been finalized for manufacturing these machines? What is the likely cost of each machine? What will be the cost of each test?
Again, this is a very common question that we have been facing over the past few months. So, of course, as all of you may understand, that interactions have been going on with various commercial organizations, starting from very reputed companies or well-established companies to startup units, about taking this further forward. So, and the institute has a structured procedure for technology transfer, commercialization, licensing, etc. And institute is very much open to execution of that, subject to the following due procedure. Regarding the cost, well, here I actually mentioned it very clearly. So it depends on the level of sophistication that you want to impart as a part of the machine, part of the testing kit and so on. So currently the cost structure that we have worked out, the machine, what I wanted to inform all of you is that because of the lockdown period, this entire machine has been built within IIT Kharagpur without taking help of any professional organization outside the campus. Our younger faculty members, students and technical assistants of various levels within our own lab and system, they have actually developed this by buying individual components and putting this together. So keeping that in view, whatever cost I will say, in an upscaled commercial environment, the cost may be different. So this is around 5,000 rupees per machine that we could fabricate this. Regarding the cost of the kit, it again depends on how many paper strips you will be using and all these things. So we are currently working out certain things to minimize that. So currently whatever is being used, if we improvise that to a commercial level, we expect that the cost per test that the patient have to give without government subsidy will be around 500 to 600 rupees. With government subsidy and intervention, the kind of thing that government has done for Rtpcr tests, if the same thing is done for this can go further down.
The next question is from Anunada from Hindustan Times. How is the RNA extracted in the process? Could you please explain the heating steps and how is the paper strip different from the Feluda strips?
Okay, so let me explain these things one by one. So RNA extraction is not a part of our innovation, which means that RNA extracted in any way which is acceptable as per ICMR guidelines in India and outside India, whatever are the relevant guidelines, FDA, CE, etc., those can be applied. So we have tested in our lab that this is flexible enough to accept any form of sample. That means we could have a separate swap to RNA conversion unit and integrate with this extracted RNA from an established RNA extraction unit that also can be put as an input. So that flexibility is there and we have absolutely no restriction on the method of RNA extraction so long as it is approved by the appropriate regulatory authorities. In India, the regulatory authorities are ICMR. Regarding the heating steps, the first part of the step is known as the basic RT lamp step, which is the basic test procedure based on which we have improvised further. So it is exactly the same or very similar to the RT lamp. The subsequent heating step which we do to improve the quality of the result, this is our patented thing and it is not copied or it is not a reproduction of any other publication or method existing anywhere in the world. So this is a patented step and I do not want to discuss this until and unless somebody comes to a clear non-disclosure agreement terms. But that is a simple step and a very short step that I can mention. And regarding the paper strips, yes, the Feluda strips, so-called Feluda strips, what has been discussed for some time, the same strips can be used. In fact, the cost expenditure backbone of our test is similar to the cost expenditure backbone of the Feluda test. That means that cost wise, if it is put in a common perspective by a commercial agency, there will not be much of a difference, but scientifically there will be a clear difference because the final detection in the Feluda type of strip is done using a method called as CRISPR based detection, which is essentially an RNA based detection. Because RNAs are unstable, there is a questionability about the stability when it is transported to a remote place, when the kit is being transported to a remote place and the testing is done. we have not followed that particular detection step and innovated our own detection step, which is very much different from any other method. The advantage of this is high accuracy, which gives sensitivity of the test outcome quite good, but not just in the lab. When the kit is being transported from one place to another in an uncontrolled environment, and beyond that the test is done. During the testing procedure at ICMR NICET, our research team, we actually did not make a tie-up with any commercial unit for making the kit. All our professors, students, and typically the students who are expert in the biological protocol, the students of Professor Arindam Mondal's lab, they have actually managed making the kit, and these kits were transported by ordinary car from Kharagpur to Kolkata. Sometimes it took 5 hours, 6 hours depending on the traffic, and then it was kept sometimes overnight in an uncontrolled environment, and then the next day the tests were done by the testing authorities at ICMR NICET. It clearly shows the high quality of reagent stability, which is very, very essential for any point of care test. So a point of care test has to pass through several critical testing conditions, not just sensitivity and specificity. These are of course very, very important, but sometimes these are overemphasized. What is more important is several other things: how generic the test is, how flexible, how accurate, even if it is implemented under difficult conditions where untrained personnel can do it, where a machine which is not as established as an Rtpcr machine or even a simple PCR machine is used for doing the test. So I think that these are the particular points where we wanted to put our innovation a little bit different from what others have put up.
I would also like to add one small thing over here, that there is nothing called Feluda strips. So these strips are very simple paper strips which are available commercially. The unique thing is the method which enables the strip to detect the infection. So these strips, there is no like specialized strips which are getting used either by us or by other methods. So it's the method which is unique to individual groups.
Absolutely, absolutely.
Mr. Colin Roy asks, is there any difference in sensitivity and specificity in field conditions, and how does it compare with RT-PCR? Can you quantify it?
In field conditions, the general intention is actually not first to directly go to the field and do it, but within the laboratory environment, simulate a field condition. So this is a practical way of taking a particular method from lab to the field. So that we have done in various levels. First is preparing a structured guideline. In fact, we have, because of the limited time of this meeting, we have not been in a position to demonstrate this, but it is known by the testing authorities of ICMR NICET, including the director of ICMR NICET, that we have prepared a write-up in a simple language which is converted to a regional language, in our case Bengali and Hindi, and of course it could be translated to any language, which is a clear set of instructions which can be followed by any minimally trained person who just knows how to read instructions and follow the instructions. It doesn't require a sophisticated, highly trained molecular biologist, as Dr. Chawla Sarkar rightly mentioned, to do the test. We also could test various versions of, as we went through these exercises of testing patient samples and simulated samples, we made a large number of tests where actually we did not do the test within the lab itself, and the video that we have shown here, this test was actually done in a green field, which is outside any lab, and it was the machine was put up in a table, the sample was handled as it is, and this test was conducted. So, but having said that, there are clear steps to go forward. The first part of the validation was the method itself. So the method has to be first very accurate, and then the question of these things come. Many organizations come up with very fancy kits and devices, which they claim that in 1 minute they will be doing the test, in 30 seconds they will be doing the test, can be put anywhere, looks very fancy, but the scientific backbone of the test is not so much rigorously established, and that makes many of these tests fail under different conditions. We did not want to go by that route, being ourselves scientific personnel in an educational environment. We wanted to go through these steps one by one. So first we established the method, then integration of the method with the machine, then integration of the method with the machine to an extent that in a simulated field environment where the conditions are not high-end laboratory conditions, including the air conditioning, controlled at ambient operators, etc., we could successfully do it. And of course, the next step will be to implement it and test it in real fields in large numbers. So that is the way in which we are moving.
Our next question is from the Prince, Sonia Agarwal. She asks, IIT has already applied for patent. Is there any outcome?
Yes, of course. So as soon as we innovated this method, we filed the patent. Those of you who are familiar with the patenting procedure will know that after patent filing, it takes some time to get it approved. But once patent is filed, the intellectual property is completely protected, which means that any technology transfer, commercialization, etc., can be done as per the intellectual property described by the filed patent as per patent law.
Sonia Agarwal is another question. How different it is from PowerSure, the kit developed by IIT Delhi?
So this is again a common question that I have been facing. So this is because of lack of clarity in understanding in different kits and methods, and possibly confusing between kit and method. So far as my understanding goes, the IIT Delhi's kit which has been developed is an Rtpcr kit, which means that the test is the Rtpcr test. The kit is indigenously developed to be tested according to the method of the Rtpcr test and in the Rtpcr machine itself. Our thing is different from that in all respects, because first of all, our method is not Rtpcr method, it's an innovated new method altogether. So the kit is different, the method is different. The flexibility is that this method could be applied using a machine which can start from the high-end Rtpcr machine to the very low-end simple box that we have demonstrated. So it is clearly different in terms of method and machine. That particular kit is established based on a well-structured and established Rtpcr method which has been existing for years. This particular kit, method, machine combined is completely different and new.
Good. There's one question. What is the roadmap of developing it to be field ready and mass production to reach the last mile use?
Yes, the roadmap of from now onwards is extremely clear to all of us. So within the academic institutes, we of course have limited capability of mass production. Mass production includes mass production of the kits and mass production of the machine units. So as I have already mentioned that we are already in discussion with commercial entities, and we will be taking this forward. Possibly we will close all these discussions with them very shortly, so that there is a rapid transformation or rapid translation of this to the market, which includes large-scale production of the kits, large-scale production of the machine units, and using these in integrated either together or in separate forms with whatever infrastructure available, so that this can be quickly scaled up and brought to the common people. What the director ICMR NICET mentioned is a very important statement, that this testing method, it will find its unique application in intermediate, small scale healthcare units, like those in division, subdivision levels. Where you have some infrastructure, but not as high end as what is there in an RT-PCR lab. So those infrastructures could be used as centralized infrastructure for swab collection and maybe RNA extraction, and large number of these machine units in a decentralized manner can be put up in resource limited environment or villages well connected to those places, and that is how it could actually reach the common mass with the help of the government, with the help of the commercial entities, and IIT Kharagpur is absolutely open to these kinds of developments.
Priscilla asks, does this method use the CRISPR system?
No, this doesn't use the CRISPR system. Again, I will tell you one thing, that this is because of maybe lack of clarity in describing things in the media, that people understand things in a different way. So CRISPR or this method, or there are different methods, variants of this kind. I have clearly explained in the video that all these fall under a common ambit of a new kind of test, which is known as isothermal nucleic acid test. So what it does is, instead of doing the thermal cycling in a PCR machine, it's an innovation which is not new. It has been existing prior to this COVID-19 pandemic, and it has been picked up, and people have used it first outside India and then some organizations in India. On the other hand, the further innovation on RT-LAMP that we have used anywhere in the world, it has not been introduced anywhere in the world. So the basic building block, the structural foundation remaining the same, the further improvisations which improve the quality of the test despite the simplicity, I think that is where all these methods, starting from CRISPR to this one to maybe other variants of RT-LAMP, they will differ from one another.
Mr. Palyamre asks, how does it compare to RT-PCR? Can you quantify it?
I think this question we have already answered several times, how it in a quantified manner it compares with the RT-PCR test, but in terms of a textual summary, it is very, very close to the ideal standards of RT-PCR test that has been set up by ICMR. For RT-PCR tests, not these kinds of simplified tests. And if you go down to a little bit restricted limit of the viral load, that is CT value 30 and less, this is 99%, close to 99% of what you get as outcome of the RT-PCR test on real patient samples done using the same swab.
I think a little simplification can be done, that we have given 200 samples, and those samples were tested with RT-PCR, and then we have tested it with our method, and we have shown 94% sensitivity as like 94% closeness to the RT-PCR in terms of the sensitivity, and 98% closeness to the in terms of specificity to the RT-PCR process. So it can be defined as that.
Closing the forum.
Any other question? Yes.
So I'm sure there will be several other questions and discussions that we can take forward beyond this particular online meeting. But because of the interest of time, we may have to close this meeting. So I request the director IIT Kharagpur to give his closing remarks before we close this meeting. And on my personal behalf and on behalf of IIT Kharagpur, I thank all our well-wishers, because of whose good wishes we could complete this work despite extremely challenging times when we had infections on campus, outside the campus, and everything disrupted our activities someday or the other, but somehow we could manage with kind support from our authorities, and we therefore thank on behalf of my entire team to all because of whose support this has come to this level of success. I would request our director to give his final closing remarks before we close this online session.
Thank you, Professor Chakraborty. In fact, I'm very thankful to all the media persons who came here for the press conference. One thing I would like to say that this cannot be compared with what IIT Delhi has done. This is completely a new thing, and as Professor Chakraborty has repeatedly told about the accuracy and quality of work at an RT-PCR, I can tell you that it is very close to RT-PCR, and it's a great challenge. I would say that it is challenging the result of RT-PCR. That means you can say some location for specificity it goes to 98%, and the samples that were given. So you can understand the accuracy and the newness and the invention in the method. We have not disclosed, as very rightly said by Professor Chakraborty, but it cannot be. Nobody has done this thing so far. Otherwise, ICMR. I heard the lady from ICMR as well as the director ICMR, and I said they are so confident that this machine can be even given for commercialization, and the level of testing that they have done on the actual samples it talks volumes of the level of innovation of this particular machine. I thank you very much, and I'm sure that you will have more other questions which Professor Chakraborty and his team can always answer. We are looking for the machine to be commercialized now so that it can come up. I'm sure the pandemic is not leaving us very soon, and that's why pandemic, as he told, many other viruses may come up in future. Of course, we don't want, but yes, if there is any, at least we will be in a position to identify and test. And the other important thing which is said that in different stages we can know as to what is the stage of the attack of that virus to a person. And the simplicity, as has been told by him, talks the versatility of this machine as well as the uniqueness and the real invention that the team has done from IIT Kharagpur. Thank you very much, all of you, and hope to meet you again. Thank you.